Thank you, everybody, for coming. I'm going to present a way of how we think we can design cross-chain markets more efficiently. And for this, we will first briefly talk about multi-chain again. Why has cross-chain become so important? Everybody is talking about it. Why is it important that we solve this? Then we will talk about what actually makes cross-chain so hard to solve. Then we will briefly dive into existing solutions of other DEXs and their cross-chain solution and talk briefly about the trade-offs. And lastly, we will dive deeper into a new design proposal of how we believe we can actually make cross-chain intents more efficient. All right, let's start. Why cross-chain? I assume most of you have probably been in the space for a while and have seen a lot of dozens, maybe even hundreds new chains being developed, all of them with different use cases in mind and different advantages that they bring to the market. Probably many of those will not be around anymore in a few years from now, but some of them definitely will. And one thing has become very clear, that there's not only going to be one DeFi chain that will dominate all of DeFi, but there's going to be a multitude of different networks that will all serve their own use cases. And we need to make sure that we can serve these use cases and that we provide a good user experience by tapping into these chains. The problem is, today, there is not a good use case situation, right? Like users, they try to bridge over to different networks. They need to do research into what are existing bridging providers, what are the security trade-offs of these. They need to handle different gas tokens in their wallets. And then they also need to always look for what is the best liquidity route that they can find. So if we want DeFi to truly succeed, if we truly want the next billion users to come into DeFi, TradFi to use DeFi, we need to solve this complexity and provide an abstraction layer that allows users to have a very smooth interaction across all different networks. We have been able to solve this on a single chain in the past, right? We had similar issues on a single chain in the past, terrible UX, lots of fragmented liquidity, and then different aggregators have been built, and also intents really revolutionized the way of how we interact with blockchain. So on a single network, this has been solved. But on cross-chain, we are basically back in the past. We still provide very bad user experience. The question is why? Why is it so much harder to solve this in a cross-chain environment than it has been to solve this on a single chain? The reason is that in a single chain, you have atomicity. This gets lost in a cross-chain environment. What does atomicity mean? It essentially means that if you do a transaction, either the entire transaction gets executed or none of it. But you cannot struggle and have like only a component of a transaction being executed or take away user funds but not return the buy token to the user. That cannot happen in a single chain because you have this atomicity. But in a cross-chain environment, this atomicity breaks. So now what could happen is that you have a user who, for example, on Arbitrum, wants to sell their token and wants to buy tokens from Ethereum mainnet. And since you don't have atomicity, it's theoretically possible that you take the user funds away on Arbitrum, but you never give them their funds on Ethereum. And that's obviously a bad situation that needs to be avoided. And so what you need now is, because you don't have shared state between different blockchains that would solve this problem, you need to come up with a messaging layer in between. There's a variety of different solutions, light clients, native bridges, even TEEs. The problem is you will still have to rely on a third protocol, and of course also between different layer 1 solutions. It's much less infrastructure currently available that does the communication, that handles the communication between those two networks. Lastly, another big issue is that you have different finality periods. So just because a transaction gets included in a block doesn't mean that it will ultimately be included on the blockchain, because you have reorgs. And so you need to theoretically, you cannot just see, okay, the transaction has been included on Ethereum, now it's safe, I can now deposit tokens to the user on Arbitrum. No, because you need to wait until Ethereum has reached finality. And that takes time. So theoretically, for full finality on Ethereum, you need to wait for 2 epochs, which is approximately around 15 minutes. And for other chains, it can be longer. For other chains, it can be shorter. For Bitcoin, theoretically, it never really reaches finality, even though most people would probably argue a couple of blocks is sufficient. And yeah, so to sum it up, why interacting across different networks is so difficult is because you don't have atomicity, which means that theoretically there is a risk that you double spend user funds or that you never return funds to users. You solve this with help of some messaging layer in between that you need to trust. And then lastly, you have to deal with these delayed time periods until blockchain really has hit finality, or find a way around it to provide good user experience, because of course no user wants to actually wait 15 minutes to get their token balance updated. All right, unfortunately I would love to focus more on this section. Unfortunately, we don't have enough time for this. This would be an entire talk in itself. But there are already a bunch of different solutions live, and specifically here I'm focusing on DEXs and how DEXs handle cross-chain solutions. Again, unfortunately, no time to go into depth here, but basically, if all of these different solutions, they were taking a bunch of different trade-offs in order to handle the situations, the issues that we have just discussed. And there is one common denominator between these, which is that all of them are not very capital efficient. The reason is, if I, as a user, want to do a trade, let's say again between Ethereum and Base, then they need to have a counterparty that is executing this transaction, the trade for them, on the destination chain. So if I want the user experience to be fast, there is no time to wait for finality, there's no time to do proper bridging between the two blockchains. So what happens is that usually a party who executes the trade on behalf of the user on the destination chain is leveraging their own capital in order to get the trade done. And then later is going to be repaid from the user's deposit. In some of the solutions, it happens faster. In some of the solutions, it can actually take up to a couple of hours until the solvers are being repaid. But the core point here is, and I think it's easier to highlight this in numbers, if you're a solver and you want to only provide and support solutions for 10 different tokens across 10 different networks, and for a trade size of up to 100,000, then you have to already lock up capital of $10 million. And that's problematic because there's very few solvers, very few market makers that just have $10 million laying around that they can use to engage in this. And this is one of the core issues that we will be focusing on how we can solve this. All right. Yeah, let's go to the main session or section here. Looking at a proposal of how we believe we can solve intents in a cross-chain environment by significantly reducing capital requirements. For this, I wanted to first review again what is actually the requirements that our solution should be able to fulfill. One is that we want, of course, a connection between all networks, not just between layer 2s, but between also all types of layer 1s. We want connection between Ethereum, Solana, Tron, whatever, Binance, everything. Then we want to be able, since we're talking about cross-chain swap intents, we want to be able to also include a proper swap. Some of the solutions from the previous slide actually don't even include a swap. They merely only focus on bridging. But we want a user to be able to do a transaction that changes the token in their wallet. Really important is also that we only want to have one single interaction. So you don't want a user to have to sign multiple transactions, and you don't want a user to have to sign a transaction, wait until something has happened, then come back and then sign another transaction. We want to be able to tap into on-chain liquidity, so to make sure that the swap can actually tap into an existing on-chain liquidity pool, such as Uniswap, Balancer, or whatever. We want the outcome to be atomic, so we want to make sure that the user, either the whole user interaction happens or nothing happens. So we want to avoid that the user ends up with a token in between. Let's say they want to have, they have ETH on Ethereum and they want to have USDC on Solana. Then we want to make sure that they don't end up having ETH on Solana, but they want either they keep the balance that they originally had, or they actually receive exactly the token that they wanted to receive. And then we want to make sure that the user actually has strong competition. This is one of the big issues if you have too high capital requirements, because then you have barely anybody who can participate in the competition, and the user will suffer from this because they will receive a worse price at the end if there's no strong competition in finding the best route for you. And of course, we also want the solution to be somewhat time sensitive. Again, users don't want to wait around forever. And last but not least, the point of being capital efficient to ensure that you have strong competition and that you actually also can tap into a variety of different tokens and trade sizes. All right. So we think we can fix this. We think we can fulfill all these requirements with one single vision, which is to create one single auction that unifies liquidity and orders across all different networks. So essentially, whether a user just wants to do a same-chain trade or whether users want to do cross-chain transactions, they should all be united in one single order book for which there is one unified auction that is running. And yeah, this auction should run frequently, again, for time reasons. Of course, we want it to run fairly often. And we want to run it with a strong solver competition that guarantees that users' outcomes get maximized, that they get best possible liquidity. The challenge of this idea is that, of course, if you have a solver competition, then you need to realize that there's not one single solver that is deployed across all different networks and that is tapping into all existing on-chain liquidity. So if you had an auction where only one solver gets to win, then the majority of the transactions in the order book would either never be executed or it would take a very long time for them to get executed. So to solve this, what we now need is a combinatorial auction, which means that multiple solvers can not only submit multiple solutions in parallel, but also get to win and execute on-chain multiple solutions in parallel. The importance here is that, of course, the subset of transactions that they execute cannot be overlapping with each other. So they need to be mutually exclusive. And then you have multiple solvers that can all look at a different subset of the order book, provide solutions, and whoever finds the best route for a subset of the order book gets to execute it. And these are multiple solvers in parallel, multiple executions in parallel that can happen. This is actually a component that is already live today. There's one word I wanted to highlight here, which is that we're not just talking about combinatorial auctions, but talking about combinatorial batch auctions. A very small word, but a word that can be extremely powerful. The reason is, first of all, what do we mean by batching? By batching, we mean that we can match different orders peer-to-peer together. So if you have a variety of orders in an order book, we can actually match them against each other. Very simple example here would be that somebody wants to sell one Ethereum ETH and buy Sol on Solana, and someone else wants to sell Solana and buy ETH on Ethereum. So now you can match these two trades together, and theoretically, you don't even have to touch any on-chain liquidity. The reality, though, is that in most cases, you probably will have to have at least one on-chain interaction because the likelihood that the volumes of both transactions is exactly equal is very low. But the majority of this trade you could already settle by matching these two user orders together, and then you would have one additional on-chain transaction for settling the excess amount. All right, why I said this is very powerful, and it is, especially in the cross-chain environment, because now if you look at data, about 80% of all cross-chain volume is touching 5 tokens. So now that gives us a huge opportunity to basically have all these different transactions that deal with the same tokens to match them against each other, and then have significantly less capital requirements to just focus on the leftover trades that are not covered by these 80% and ensure that we also have a smooth experience for those. So this is already this is already really powerful how cross-chain happens today and the overlap of tokens in it. But we can actually bootstrap this even further. So there is a lot of talks about different projects currently that talk about cross-chain abstraction. Basically saying users, they don't want to know where they hold their tokens. They just want to know, okay, I have 10,000 USDC. I don't care that 5,000 of the USDC are on Binance and the other 5,000 are on Ethereum. So there's of course users who do care, because theoretically this chain abstraction also means risk abstraction, because just by the token being deployed on a different underlying network means also that you have slightly different security assumptions. But most users actually don't care, and there's specifically protocols like One Balancer who are focused exactly on this, on abstracting this complexity away and providing one single user interface that just shows, hey, this is your total balance of 10,000 USDC. You don't care where the USDC lays. And this gives us a huge opportunity, because now, if the user does not care on which network their USDC lays, that means they can have standing limit orders, where they say, you can always exchange my USDC on Base against my USDC on Ethereum, or against my USDC on Binance, because in the end, I don't care on which networks I hold it, and as long as I get a little bit of surplus for you doing this balance change for me, I'm happy. And yeah, this is a huge market to tap into, and a part of this market we already see live today. So on CowSwap today, there's already a huge amount of trading volume stemming from users who want to simply exchange one USD-pegged stablecoin for another one in exchange for a little bit of surplus. So already today, there's a bunch of users having standing limit orders saying, here, trade my USDC for USDT, for DAI, for whichever other USD-pegged stablecoin, as long as I make a little bit of income off it over time. And this is, of course, a huge potential now to tap into this liquidity and additionally use it for our cross-chain solution. All right, let's go back to how exactly the design mechanism works. So you have the one auction, and then there's, of course, an additional component you need, which is this balance sheet. You need to keep track of which orders that participate in this auction have what type of tokens in their wallet. And for this, we are introducing a ledger. Basically, think of it as an accounting layer that keeps track of the user balances. And how it would work is that a user deposits into this ledger, which actually also can be abstracted away. It would be like a smooth joint transaction of the deposit plus the trade intent that it would express in one single transaction. And then the balance gets reflected in the ledger once, and here's an important point, once finality is reached. Again, here you would say, oh, but then you have the problem again of this system taking too long if you have to wait for finality. So this is actually something that has already been solved, not by us, but by Circles. CCTP v2 introduced a very clever solution for this. They're using an insurance fund that says, okay, we do realize that real finality on Ethereum takes around 15 minutes, but de facto, if you look at the last few years, that never happens. So actually, we are already happy with a much shorter finality period. Let's say 3 blocks. for small amounts, and then of course, the larger the volume is that a user wants to settle, the longer this insurance fund would probably want to wait until they accept the deposit on the ledger and say, okay, even though the chain has not yet reached full finality, we are already fine with updating the balance sheet, the ledger, and say it's final. And yeah, and then lastly, of course, if a user ever wants to receive the token on the destination chain, again, we don't want to have a separate transaction where they have to now say, okay, I want to withdraw my new balance on Solana or wherever, but of course it will also be automatized with help of a post hook. Okay, this is basically all the infrastructure that you need. And then let's look concretely at the cross-chain settlement. It has 2 steps, or like 2 transactions that it involves. One ingredient that it involves is an update to this balance sheet, to the ledger, just saying, okay, after I do this transaction, this is the new balance sheet, this is how much funds each of the users now holds. And the second ingredient is that you need to have, or that you can have, this on-chain settlement transaction where you also use the balance and use that to interact with an on-chain liquidity pool like Uniswap, like Balancer or Curve or whatever, to do one on-chain transaction. And then what happens is the solver submits this proposed solution. They say, this is the balance update, this is the on-chain transaction that I want to do. The validators review it, the validators of this ledger review it, and if everything checks out, they co-sign the transaction, then the solver has a given period of time during which he can execute the trade on-chain. If it happens, then the solvers, the validators will update the balance sheet accordingly and say, okay, now the user has this new, basically in this case, the 3,600 USDC deposited on Ethereum. And yeah, and then this is the positive case scenario. And in the negative case scenario, if for whatever reason the on-chain transaction fails, which can always happen, right? Maybe someone removed the liquidity from the Uniswap pool, maybe the Uniswap pool's price point was outdated, and in case this settlement reverts, then very easily also just the ledger balance sheet is updated accordingly and reflects again the balance of the users before the failed transaction. Okay, and now we actually have a really cool use case, which is the one where the previous one was just one single normal user interaction. I want to do a cross-chain swap. The much more interesting use case now is that you actually have these standing limit orders in the order book that you now can leverage for additional on-chain liquidity. And in this case, you have a user who has a standing limit order. This is user 2, who has 1 ETH deposited on Base and says, okay, I'm happy to, I don't care if my ETH is on Base, if it's on Arbitrum, if it's on Solana, whatever, I just have this 1 ETH. And it's available for solvers to tap into this. And then there's a user who actually wants to do a cross-chain trade specifically. They now deposit their ETH into Arbitrum. It gets updated in the ledger, and now it reflects user 1 has 1 ETH on Arbitrum, user 2 has 1 ETH on Base. And now in the next step, the solver knows, okay, this user who has 1 ETH on Arbitrum, they want to receive USDC. They want to receive USDC on Base. So now, let's say the solver has 0 capital themselves, what they can do still, they see, okay, there is actually capital available. Somebody has 1 ETH on Base, let me leverage this. And they will submit a solution to the ledger, which includes basically the proposal that now user 2 changes their ETH balance from Base to Arbitrum, and user 1 who wants to do the trade, there is now getting this user 2's ETH on Base in order to use that funds to execute it against on-chain liquidity, in this case a Uniswap pool, to receive the USDC that they want. So it's a very elegant way to use pre-existing capital without actually having to do any bridging and just updating the balance sheet here. And yeah, the solver provides the solution. The validator set co-signs the transaction. The solver, this way, gets to execute the trade on chain. It happens. The balance sheet gets updated. This is the happy path. In the unhappy path, as mentioned before, if the transaction reverts, then the balance sheet is just reverted as well. User 1, again, has his ETH balance on Arbitrum. User 2 has their ETH balance on Base. Simple as that. And yeah, while in the past, we have been trying to solve DeFi a lot in silos, we are really now trying to break these borders across different networks. And this is exactly what our solution here is trying to achieve by having one platform with one auction and one unified user experience across all existing networks. That's it. Thank Mu.
Thank you so much. What awesome. Thank Mu is incredible. I love that's an awesome slide. So we have, again, a bunch of questions from the audience. I mean, that was incredible. I think one thing that when I think of interoperability and cross-chain, it's like today's experience of going from one chain to another is like if you were using Google Chrome and every time you were going from one website like Facebook to another website like, let's say, LinkedIn, you had to change your Wi-Fi router. It's like this arduous process, right? You got to change the RPC, all this sort of stuff. And having it actually feel like one chain and having cross-chain liquidity and coordination be solved is will basically make DeFi feel like the internet today itself. So first question that we have is, do we need to solve the multi-chain problem on an app layer or a chain layer?
Ooh, that's a good question. I would say on both. Of course, there needs to be infrastructure, how different networks coordinate better with each other, but I think it has its limits. You have layer 2s that are, of course, working on interoperability with their base network, but I think it's unrealistic that networks like Solana, Ethereum, Tron, etc., will come up with their own perfect solution how they can be more interoperable. So I think there will always be a component that has to be also solved on the app layer.
Awesome. How do you think about trust when it comes to this?
Yeah, for us, it's very clear that the reason that we are on blockchain, right, is that we don't want to have to rely on trust. So whatever solution we build, we want to build it fully decentralized and in a way that we can minimize trust as much as possible. So this is why we haven't published any concrete details yet about our ledger solution, but of course the idea is to work with a very secure validator set in order to remove any trust assumptions for this. For us, it's always been a core. I think if you know the background history of CowSwap, the very first protocol we actually ever worked on was by external parties always categorized as the most decentralized protocol out there. It had the disadvantage that if you're just working on it heads down, fully working on decentralization, it takes a very long time to go public with it, and you might miss user needs. This is what happened to us back then. So when we designed Cow Protocol, we tried to go a little bit more loose on not being fully decentralized from the get-go, but it is our vision. This is 100% where we are headed. We want 100% decentralization.
Awesome. Yeah, and you have users today that you listen to, that you get feedback from, and I think the way you've structured it has been awesome to see. How do you protect limit orders on risky asset pairs from toxic overflow?
I mean, the good thing about limit orders on CowSwap is, right, that you basically, it's the only limit orders that can generate surplus. So, I mean, with limit orders per default, you're protected in the sense that, at least with out-of-market. Oh, I guess maybe this is not asking about out-of-market limit orders, but in-market limit orders?
It just says limit orders. I imagine in-market.
Okay, if I answer your question wrong, find me later and talk to me about it. I might misunderstand it. But the cool thing about CowSwap limit orders is actually that obviously if it's out of market, the only way that they get filled is anyway if the on-chain price point is hit. But the cool thing on CowSwap is that actually since we have the strong solver competition, in many cases users get more like a better price than the limit order, which is the only protocol that actually does that. Yeah. So a few weeks back, when we had this flash market crash, and a lot of protocols, a lot of SEXs, centralized exchanges, actually didn't work. Like the limit order feature just didn't work. The orders didn't get executed. Yeah. CowSwap still worked, and a lot of users had very positive feedback because they actually received better price points than what they had been asking for in the limit order.
Yeah, I mean, like DeFi just works. It's incredible. Yeah, I guess in terms of what you would want the protocol to do to better assist you, is there any requests that you have or something that you wish you could see on the protocol layer?
You mean that we would want from base protocols in order that would help us? In general, I think we have been very strong advocates on solving MEV, and we think that it makes sense to solve it on the application layer as much as possible. I still think that's also something where the base layer could probably additionally help. Yeah, but in the end, I think we always try to optimize for users as much as possible as what we can do from the application layer. And on the other hand, I think also base layer, it's good that they focus as much as possible on really like just core issues to ensure that they keep being decentralized. I think it's, once you start giving more requirements to the base protocol, it's a slippery slope of them adding too many policies that might harm decentralization. This is something that we have actually seen when Ethereum implemented proof of stake as a component of like decentralizing the validators, et cetera, that actually led to a huge decentralization from block builders, right? And that was like a response to trying to solve the MEV problem. So it ultimately, to some extent, made it worse. So I would say I would keep the base layer as simple as possible and try to focus to solve a lot of the UX issues on the application layer.
Awesome.